Okay, our last video that we're going to look at is solving an exponential equation, but now using logarithms to solve it instead of the way we did before. So a quick review, if we had a question before where we had 4 to the x equals 64, remember what we did is we changed both sides to have the same base, so we changed 64 to be 4 to the power of 3. And then once we had the same base, our exponents then were equal. So that was a pretty easy way to solve these. But what happens now if our equation isn't possible to make the bases the same? So if we go 4 to the x equals 25, we can't make the 25 and 4 have the same base. So we're going to have to come up with a different strategy. So if we use our log formula that we change exponents to logs, we can get this to work better. So if we say x equals log base 4 of 25, those two things are the same thing. And we know that we can actually do this on our calculator, right? We can't put in log 4, but what we can do is go log 25 divided by log 4. So on our calculator, if we type that in, log 25 divided by log 4, we get an answer of 2.32. And we can always go back and check that, so you could go 4 to the power of 2.32 on your calculator, and that will give us the answer of 25. So we know we've done it right. So it's a pretty good strategy that anytime you get a question that's an exponential equation that you can't solve by making the bases the same, you can always solve these by changing them to a logarithm. So let's try another one. So let's suppose I give you 5 to the x plus 3, and that's equal to 20. So once again, we can't make the bases the same, so let's just change it to a logarithm. So that would give us x plus 3 is our answer, equals log 5 of 20. Okay, so just like we do before, let's figure out what log 5 of 20 is by dividing. So log 20 divided by log 5. So when you do that on your calculator, we get an answer of 1.86. So now we just do like any other equation. Let's subtract the 3 from both sides. That means x will equal negative 1.14 if we round it off. And that's it. So it's the same sort of idea, just switch it to logs first, and then from there solve the regular equation. Okay, with a question like this, there's a different way we can actually solve this. So I'm just going to show you sort of a different method, but it gives you the same answer, and it's basically the same thing. So our original equation is like that. Instead of switching it to an exponential or to a logarithm equation, there's just like when we solve equations, if you square both sides, or you can square root both sides, or times by 3, or whatever. For a question like this, we can actually just write the log in front of both sides as it is. So we can just write log 5 of x plus 3 and then log of 20. So that doesn't change the question by putting a log on both sides. Now we can use our other exponent rule where if we have something as an exponent, we can just bring that down in front. So this would be the same thing as x plus 3 times log 5 equals log 20. And then now we can divide by the log 5 on both sides. So that'll give us x plus 3 equals log 20 over log 5, which from there is exactly the same as what we had previously. So I won't bother solving the rest because it would be identical. So it's just a different way of approaching it. Instead of switching it using the log conversion formula, just do the log of both sides and then bring the exponents down and solve it that way. So let's do one more. So this one will be very similar, except let's do one with a log on both sides. So if I give you 5 to the x minus 1 equals 3 to the x plus 1, let's use this new method. So we'll just do the log of both sides the way it is. Oops, x minus 1. And on this side we'd have log 3 of x plus 1. And now we got to take those exponents and bring them down. So let's remember that whole x plus 1 is our exponent. So that'll be x minus 1 log 5. And on the other side we'll have x plus 1 times log 3. Okay, and now remember log 5 and log 3 are just decimals, so let's actually figure out those decimals. So log 5 is 0.69 or 0.7 roughly. So that would be x minus 1 times 0.7. And on the other side, log 3 is 0.48. Okay. Remember, by doing the log on both sides, we're just going to assume it's log base 10. So we don't ever have to worry about doing any kind of division thing. That'll make the question easier. So now once we FOIL these out, we'd have 0.70x minus 0.70, and on the other side we have 0.48x times 0 or plus 0.48. Now we just solve that equation like we normally would. Let's combine the x's. So that gives us 0.22. And let's also add the 0.7 on the other side while we're at it. So that would be 0.22x, and then on the other side we'd have 1.18. So now all we have to do is divide those out. So 1.18 divided by 0.22. Right? Get rid of the 0.22 on both sides. So that'll give us x equals 5.36. So it'll work, just a little bit more math involved, but it's the same sort of process. And remember, you can always go back in and double check these. So if you go 5 to the power of 4.36, if we subtract the 1, and then we go 3 to the power of 6.36, when we add the 1, we will get the same answers. If you round these off, we've rounded decimals, so our two answers on each side might be off by a little bit, but they're going to be pretty close. So because of the decimals are rounded, it changes it a little bit, but for our sake, that's accurate enough. And we're done.